Romania.
Hello, my name is Ana Maria Tudorache and I'm also a student in an 11th grade at the International Computer High School of Bucharest in Romania. In this video, we will present you our project, which is entitled Microsensors Monitoring Devices regarding the rehabilitation process carried out after orthopedic surgeries of the lower limb, and we will explain the reasons why we chose to tackle this subject. We believe that the quality and the efficiency of the medical rehabilitation process is essential in restoring as much as possible from the motor function of an affected limb. We tackle the group of patients whose medical recommendation is to walk with partial weight bearing, which means they should not sustain their whole body weight on the affected limb. In order to help them, we plan to improve the methods of quantifying the pressure that they are applying and therefore smoothen their path in medical rehabilitation.
The main reasons why partial weight bearing is recommended are arthritis, osteoporosis, and fractures. Annually, 1 in 5 people are affected by arthritis and 1 in 4 people are affected by osteoporosis. Comparing fractures to memory cancer, while the first one occurs to 1 in 6 women and the second one to 1 in 9 women, the similarity is significant. Realizing the high occurrence of these conditions, we wanted to help. In our project, we use piezoelectric sensors that work as a conversion device. When a mechanical pressure is applied, they generate an electrical potential that is easily quantified. During our project, we tried different materials and designs for our insole. The first one was with 5 piezoelectric sensors that worked individually and measured the pressure in specific spots. Our second design was similar to the first one, but we used different materials. We used polymer pieces that have a high resistance but a lower sensibility and couldn't measure small pressure differences. We realized we needed to measure the pressure of the whole insole, and we tried to do a one polymer piece, but it had the same problem as the second one. It couldn't measure small pressure differences. After several tests of efficiency and accuracy, we decided to go with the piezoelectric sensors. They are less resistant but more sensible and will help us quantify the pressure applied by the patient.
Our prototype includes 2 Arduinos. One of them receives the signal from the second insoles, reads the values and converts them into integers from 0 to 1024. Whenever the signal is greater than the maximum value recommended by the doctor, the signal is sent through Bluetooth to the second Arduino. The second Arduino receives the signal. A buzzer generates a sound alert that lets the patient know that he exceeded the maximum value allowed. Besides that, on an LCD screen attached, the number of total steps and of wrong steps will be displayed in real time.
Our prototype is composed from a set of second insoles that have 5 piezoelectric sensors connected into series in order to receive the signal and quantify it from the patient while they're walking. It was designed in order to be worn during the rehabilitation period outside the hospital so that the patient can carry out his daily life activities but don't interfere with the rehabilitation.
After several trials, we decided to replace the Arduino Uno from the first version with Arduino Nano that has significantly smaller dimensions. This was one of the main changes that granted us the smallest, most comfortable and most reliable version until now, that is easier for the patient to wear on his ankle. Moreover, in order to get rid of the wires through which we connected the parts, we replaced them with copper connections on a textolite base, therefore reducing the risk of having unwanted electrical signals that could minimally harm the patient while using the device. For the second part, the design differences are quite striking and they can be easily observed. We replaced the Arduino Uno with the Arduino Nano, whose dimensions are significantly lower, but it performs exactly the same tasks as his larger version. Moreover, as in the first part, we replaced the wires with copper connections on a Textolite base. Despite these differences, all of the other elements were kept the same, but arranged in a more compact and comfortable way for the patient, without the risk of tangling in the wires while carrying it around. We created the program in such a way that whenever the maximum value decided by the doctor is exceeded 10 times, the device considers it one wrong step and generates the sound signal to alert the patient. We did this change because sending a large amount of signals through the Bluetooth may cause interruptions or wrong interpretations of the data. Therefore, we considered 10 steps as being one wrong step. For now on, the experiment is performed with one single piezoelectric sensor, but in the near future we plan to connect the insole to the device. Whenever the signal is exceeded 10 times, the second part of the project will generate a sound. And as it can be observed, the number on the screen will rise by 1. We thank you for